Okay, hi, I'm Roy Rapoport. I work for a small subscription streaming company called Netflix out in San Francisco. You should check us out if you haven't heard of us. Today, I want to talk a little about sort of really operational insight concepts. This came out of a conversation I had with my boss maybe about a year or so ago. I had a new boss and he was trying to figure out how we would actually figure out whether or not my team, Insight Engineering, we're responsible for building operational insight systems for Netflix, figures out whether or not it's doing the right thing. So, the first thing we talked about is, well, clearly if you're doing your job, our mean time to detection is going to be better. And if you're doing your job, our mean time to recovery is going to be better. And I was like, meh. I like MTTD and I like MTTR. It's just that our insight systems are actually used for everything at Netflix. So they're used as a part of the development process. They're used as part of some performance testing. And just looking at recovering from incidents, which is what TTD and TTR are all about, seemed limited. So we thought about it for a while, and then we come up with a model to think about, how we think about operational insight, and that's what I want to talk about today. I'm hopeful this is relatively universal and yet useful. It might be universal and then just so obvious that it's not particularly meaningful. I'm looking for feedback on that. So I want to start with something that's obviously very near and dear to all of our hearts, which is the Korean War. 1950 to 1953, North Korea and China on one side, the UN forces and the US on the other side, a whole bunch of fights happening. One arena in which we're seeing a whole bunch of conflict was in dogfights between MiG-15s on the left side of the screen and F-86 Sabres on the right side of the screen, and an Air Force pilot called John Boyd who did a study of dogfights and came up with a model of basically how fighter pilots sort of did their job. And it involved something like this. Say you're a fighter pilot and you're flying around and you're looking around at the sky because you probably should not be looking around. And then at some point you see another plane, right? And then the first thing you need to figure out is, what does this mean? Think of it as an orientation. Good plane, bad plane. Let's say it's an enemy plane. Then what do? You could, retreat, you could attack, figure out what you're going to do, and then you start executing on what it is that you decided to do. For example, if you decided to attack, then, you continue to fight toward the other plane. At some point, you decide that you're close enough to actually fire on the other plane, so, you go back to, making a decision to fire, you execute on that, you see what happens. Boyd called this the OODA loop and hypothesized that basically the pilot who executed on the OODA loop faster was the pilot who got to fly back home. In the best case, if you were the other pilot, you got to walk back home, and it was a long walk. This was a model for talking about dogfights. If I was to tell you that I thought of this as, I was the first person to think of this in the concept that is outside of dogfighting, I would be wrong. In fact, there's a Wikipedia article that talks about the OODA loop, and in fact, Adrian Cockcroft, hi Adrian. So Adrian's talked about how Netflix moved to the cloud because we can then basically execute the OODA loop on strategic decisions faster than our competitors. A lot of people have talked about the OODA loop as basically a concept in conflict against other human opponents, and that's exactly correct, except that I would actually argue that the OODA loop is essentially what we do on a day-to-day basis. Because generally speaking, for a lot of us, what we do is, we're flying around, and for us, that might look like, looking at graphs, right? So these are the two most important graphs at Netflix. The top one is the number of calls in the queue to customer service, because, the only reason people call us is if they're unhappy. Nobody calls Netflix because they're trying to buy more movies. And then at the bottom graph here is what we call streams per second, which is the number of times per second that customers have actually hit the play button. And for each of these, you might notice that there's a red line and a black line. The red line is this week, black line is last week. These are highly diurnal cycles, so each one of these peaks is essentially a day. So you're looking at this, you're flying along, and then at some point, something bad happens. And one of these lines starts looking very different from the way it was supposed to look. And then you need to figure out what the hell it means and what you're going to do about it. This is actually a picture of one of our developers, which explains something about the quality of his code. So when you look at OODA and you start thinking about how you might measure your effectiveness in executing the OODA loop, what we think is that maybe there are really three sort of facets to that. One is the speed at which you execute this. So in other words, if you think about this as a loop that you go around, how quickly can you go around? How quickly can you come up with a decision? How quickly can you execute on that? The other one is the effort. Generally speaking, you could probably say that they're correlated, right? If there's less effort required to go through the OODA loop, you'll be able to go through it more quickly. But when we talk about effort, it's largely about human effort because we're trying to make people's lives easier and because we have more important things to be doing with our lives than making these sort of decisions. And lastly, it's about reliability. And I want to talk a lot about reliability a little bit because in this context, I would argue that the reliability of your OODA loop execution comes down to really two things. One, how reliable are you at making the right decision? And two, how reliable are you at executing on that? We can give you telemetry that might cause you to make the wrong decision, and that's bad. Or we can give you telemetry that helps you make the right decision and then give you orchestration systems that are terrible and will make it really easy for you to click the wrong button. Not that that's ever happened last week. But generally speaking, those are the three ways you can look at how well you do this. And what we're trying to do really is increase speed, drop effort, and increase reliability. And that's actually it, right? 6 minutes into the presentation, that is the key to how we think about operational insight and what we're trying to do. So what does that actually mean? Well, if you think about these four areas, observation, orientation, decision, action, from an observation perspective, it means that we want to make it really easy to observe what's going on, which means that any kind of system where, for example, you have to open a ticket to get something measured in your systems is, I would argue, a de facto terrible system. I've worked in those kind of organizations where you have monitoring high priests where you have to open a ticket, typically also provide a goat and some gold. And it doesn't scale very quickly or easily. And speaking of scalability, if people want to monitor, the last thing you want to get to is the point where you say, we love that you monitor, but we can't handle any more metrics. So you really got to make sure that you sort of scale ahead of customer demand. And you want to make it pluggable, right? So we think of Atlas, our open source telemetry platform, as a data platform. So Sergey Fedorov, who's going to speak here tomorrow, is going to talk about how his team at Netflix has built a completely different sort of remediation system on top of Atlas data. And lastly, eventually you want to be pretty ruthless at calling out metrics because really every metric should have some sort of reasonable answer to the question, what decision will this help you make? And to demonstrate this, I would like to tell a terrible joke. I do those quite often. This is also a very long joke. I've been working on telling it for about 4 years. It started in Velocity 2011 when I went to a presentation by somebody who's hopefully not in this room. And they said, I believe this is an exact quote, monitor all the things, which I found really inspirational. So I went back to the office and I used some, relatively rudimentary Bash and Python scripting, which frankly explains every code that every thing that I've ever worked on. And I came up with this thing that measures a bunch of things in our environment. It's at super low granularity. It's only about every 5 minutes, but it's been going for about 4 years. So this is actually about 384,000 data points. Anybody want to take a guess as to what this is? I'll make it a little easier. The upper bound here is 52, and the lower bound is 48. By the way, this is an actual graph from something that I actually spent time coding up, which tells you something about my commitment to terrible, terrible jokes. And the thing is, this is so sort of like explicitly funny. There's a whole bunch of metrics in your system that are about as useless, but no disrespect intended, far less funny. So from an orientation perspective, I think you've really got to look at that sort of orientation problem as a first-class problem. This is something we got wrong, frankly, when we started doing this at Netflix. We built this first-class data platform with a whole bunch of really smart distributed systems engineers, and one of these distributed systems engineers took the bullet for the team and spent some of her precious time building a UI that was, kind of okay, but not great. We think of UIs essentially as a first-class product for our team. That means that we've hired a UI engineer, and the funny thing about having great UI engineers is that, once you hire one, you end up hiring a second one and a third one. Last week I, opened a headcount for a fourth one. It's fun. And partly it's because if you start focusing on the decisions your customers are trying to make with your data, you can start really focusing on what data visualization you can offer that will help enable these particular decisions. And lastly, about orientation, I would say that the goal here should really be low cognitive load, not necessarily, spiffy graphs with high refresh rates or even data density. As an example of this, we have this canary report that we've built. Somebody in the back tell me, generally speaking, what you get from this. The good news is, if you were sitting in the front, you wouldn't actually be any better off. Or if you got this in email. The next version of this was actually a lot easier, because really all you need to look at is, oh hey, it's green and it says okay. Ship it. Which is in fact basically what we do. For decision systems, it's worth noting you've already got this, right? What are alerts, if not essentially a very rudimentary decision? Oh, hey, this metric went over this threshold. I should tell somebody about that because somebody told me to tell somebody about that. And this is something where you can do ongoing incremental improvement, so you can basically sort of improve your system's ability to figure out what's going on and whether or not there's a problem. This is probably the area where I would say we have not yet met the limits of the impact we can create in our environment. So this is a huge area for both in terms of what you can actually do with it, and also in terms of how much you can spend on this. Lastly, from an action perspective, I'm going to make some fairly obvious statements. For one thing, I think that humans can operate faster than bureaucracy. Otherwise, you should probably get better humans. Machines can actually beat humans. Otherwise, you've got really great humans. And when you have a repeatable process, it typically beats a one-off both from a reliability and a speed perspective. And if you think of sort of like transitive properties, really what you get here is if you've got something that a machine can do repeatably, it can pretty much beat human effects all the time. I'm not saying automate all the things necessarily. It makes sense to start with humans, but anytime that you get to a point where you're getting into this like if this then that model, people have talked about runbooks. I think runbooks are a fantastic thing as a design criteria for building machines to do that kind of stuff. But that's just me. So those are sort of the implications. Let's talk a little bit what that actually looks like in real life, at least in our environment. I've worked in environments that had alerting on CPU, for example, on your servers. So if you got more demand on your servers, you could maybe launch more of those. And that's great. So if you look at our current environment, this is the request load against our front-end systems-ish. The good news is this is not even something we have to build because Amazon provides this out of the box using auto-scaling groups, where basically you can actually have the system look at request load, CPU, or pretty much any metric that you want, and scale up your systems and scale them down, which is why I picked a random application that serves this kind of load, and this is the number of servers that it actually has. You can see that it matches relatively closely with request load. The lines are much more jagged. If you want to catch me later and ask me about that, I can tell you it's boring and not particularly interesting. Let's talk about canaries. So we've been doing canary analysis for a while. I think this guy, by the way, served me coffee yesterday. And back in the data center, it worked reasonably well. What you would end up with is basically a dashboard that compared the old system with the new system and make some sort of, decision. So, you start with maybe like 3 graphs, like, CPU, memory, and, request, and you just compare the old one to the new one. And then you find that that's not actually enough, so you come up with a more complete set of graphs to help you make a decision. There we go. And you sort of lost again. Because actually, when you're looking at this many graphs, they're no longer actually providing you with orientation. Really, this is just a bunch of data bombarding your palette. And that creates a bunch of problems. You've gotten a lot more precision, but you're losing context. You're actually losing sort of like the holistic understanding of the system. It also means that you have absolutely no repeatability. So, you know, two different engineers will look at those graphs and come up with completely different decisions as to whether or not to move forward. I mean, heck, the same engineer could look at those graphs and come up with two different decisions based on, you know, frankly, whether they're feeling optimistic or pessimistic that day. The other problem is if you don't have the ability to ongoingly sort of, you know, trend how your canaries are doing. And lastly, quite tautologically, manual effort is in fact manual. I think you cannot disprove that. And we try to, generally speaking, hire for laziness. So what we ended up doing was we first automated the analysis. So, you know, this worked. It took some time and effort and some analytics people, and that worked reasonably well. Presentation really mattered. This is the two versions of the report that I showed earlier, and that was a good start. But really what we did was we just automated it all the way to the decision and then had humans essentially execute the will of the machine. That's okay, but then the obvious next picture is, I think, pretty much nicer. In our current system, basically, you know, you check something into your version control system, it results in a build. In this model, for example, let's say we have 1,000 servers running version 101 of this application, and we now have one server running version 102. Roughly, that means that that server is getting about 0.1% of our traffic. Our canary analysis system will compare the two, decide that looks pretty good, tell our orchestration system to increase the commitment to the new version. So we now have, let's say, 10 servers. So 1% of our traffic is rolling out to the new servers. And assuming that that looks good, we will increase our commitment to this. And now we're running at about 2x our normal capacity. 50% of traffic is going to 101, 50% is going to 102. And the last step is to make sure that that still looks good. And if it does, then great, we're done with this. And we can get rid of the 101 version. On the other hand, it might be that the canary analysis system might decide that actually that doesn't look so good, and then we can basically take the 102 servers out of load. We could either kill them or keep them around for analysis and testing, but either way our customers are not impacted by that. I grabbed some stats for canary analysis in our environment. Not everybody's using automated canary analysis yet, only maybe about 5 or 6 different teams. And in the 4-week view of mostly, I think, May, we performed about 6,309 canary analysis cycles, and of these, about 16% failed. Is 16% good or bad? I don't know. I'm an optimist. I like to think of this as, you know, one, that means that developers took some risks in pushing out stuff so they could move faster because they counted on the canary analysis system to, you know, help them not negatively impact our customers. And it also means that, you know, 16% of the time we actually helped our customers not get impacted by bad code pushes into production. The last example of this I want to talk about is outlier detection. Outlier detection at scale actually is a lot easier than outlier detection in the small scale. It's easier to notice if you have, let's say, 1,000 web servers, all of which should be alike, what the right behavior is, because you can essentially deduce the right behavior just from the, you know, the herd behavior. This is sort of like the high school algorithm, or at least was my high school algorithm. And outlier detection turns out to be actually a relatively easily sort of solvable analytic problem. And to demonstrate this, can I ask for a volunteer, ideally from the front row? I will throw in a 2-month free subscription to Netflix if that helps you make your decision. Jamfish, fantastic. Here, I'll make sure that I hold up my end of the bargain. By the way, it says that you're supposed to scratch the back with a coin. This offer does not include a coin. So, I'm going to ask you to notice an outlier. Here's, I've got some, training data. So imagine each of these columns is a server. We have servers A through I. We have some number for each of these servers for a given minute, 0 through 10. I would argue one of these servers is kind of not normal. Can you notice which one it is?
Server E.
Anybody else agree with her? Okay, those of you not raising your hands, you probably just are the kind of people who don't raise hands, do you? Okay, good. So that was a great test. Let's actually use more realistic data. Ready? Fantastic. Let's go. Do you mind if I time you?
Sure, why not?
Excellent. By the way, no stress. It's not like our customers are impacted right now. Somebody just came back from school and they can't stream because of you.
Based off averages, I'd say A is a little bit high.
Okay, cool. This is actually pretty hard. It took you about 25 seconds. That was actually a pretty good guess. I'm not sure it was a really well placed
It
guess.
wasn't well because there's a whole lot of them with higher scores than the
Yeah,
others.
but it was actually a really good guess. And the good news is, frankly, guys, who's going to look at a bunch of numbers to make this? What we're going to do is we would just put it on the graph, right? So let me make this easier for you, right? This is the same data, and I'll give you a few seconds to make a decision. You can stick, by the way, to A if you like, or you can maybe choose,
At this point, I'm thinking it's E.
Oh yeah, okay, good. Great. So it took you about 21 seconds. You decided on E. Great. Let me.
After laughing really, really hard for like 5 minutes.
That's my fault. Yeah. So here, let's try this a third time. Okay. Ready? I'm going to time you.
Hey.
Okay, that was like much shorter, and still you laughed at the beginning. Okay, good. Thank you so much. So about 4 or 5 of our clusters are currently using automated canary analysis to actually just automatically terminate instances and replace them, which means that our developers don't have to pay attention to this kind of stuff, and our customers are impacted by this a lot less. In the same 4-week review that I talked about earlier, we killed 739 servers. Each one of these was actually negatively impacting our customers in some sort of small way. So, what does it all mean? I go back to this whole OODA thing, man. You got to have observability, certainly. I've got links here, by the way, and of course we'll share the slides, both to the presentation we made about Atlas, our open source platform. I think it's a pretty good way to solve the observability problem. It's not the only way. I am one of the people who's not here to sell you stuff. The other link here is to the Metrics 2.0 manifesto, which I think is spot on and is not ours. But once you have that, I think really what it comes down to really is sort of looking at the decisions you need to make in your environment and understanding well the set of decisions you need to make. And for each one of those decisions, if a human being needs to make those decisions, that's great. But really look at the orientation step as a way to make it easier and faster and less painful and more reliable for them to make the right decision. And ideally, what you want is to get to the point where machines both make the decisions and then execute that. You do that, you get into the point where you have higher speed, lower effort, and higher reliability for your OODA loop, which is, in fact, all I've got with about 7 minutes to go. Can I take questions? Yeah. Fantastic. I will take questions assuming you have any.
So the automatic canary is really great, but how do you decide what metrics you're measuring on? What is the indication that it's going right and wrong? If you're deploying a new service, can you automatically canary it, or is there still a manual process of monitoring, deploying, and figuring out what's going on?
Good question. So the question was, 1, how do you decide what metrics are important for your canary? And 2, how do you canary test a new service? I'll answer the second question first, just to confuse people. And I would argue that canary analysis is about comparing a baseline to a new version. So generally speaking, I would say we do not canary the first release of a new service. And also the first release of a new service, potentially, unsurprisingly, is one that involves a lot more humans looking at graphs and sort of figuring out what's going on. But as for the metrics, so in our environment, you can actually, an application developer can choose what metrics are relevant for their canary analysis and how much they weight it, and it's all very complex and rich. But generally speaking, it doesn't have to be, because there are some reasonable assumptions you can make. For example, CPU per request is a reasonable metric. Errors per request is a reasonable metric. I think if you do that, you've got a pretty good baseline that'll probably catch you at 80% of the time, right? Like, if you end up with something that gives you, you went from like 1% error rates to 30% error rates, maybe that's probably bad. Does that answer your question?
Yep.
Good. Who else? You, sir. Actually, wait, yes, can I? Yeah. Very good. Look into the laser with your remaining eye.
So the question that we have is something that my company is dealing with. How far back do you look when you're actually comparing metrics? How relevant are older metrics, and what do you consider an older metric?
So the way we typically do it, the metrics we value the most are the right now metrics. So remember, the whole idea is that you're running both versions at the same time. Your load over time might change, maybe the Super Bowl happened yesterday. So really it's how the baseline system right now is operating compared to the canary system right now. Now, it turns out that some of our developers actually also like to compare, once they've done that, once they've removed the baseline system, how the new canary system, which is not 100%, compares to the old baseline system at 100%. I'm not quite clear that that's hugely valuable, and that's not the part where we usually catch the problems. Oh, I'm sorry, the question was, how do you value older sort of past metrics? And my answer is, you generally don't. You look at now metrics across both systems. Did that answer your question? Good. You, sir.
Kind of tying the previous talk with yours.
Yeah.
Given the orientation and the importance of like building the right views and visualization, how do you kind of weight the more tools versus custom tools versus off-the-shelf tools to kind of give you those orientations?
Boy, howdy. So I did a keynote at QCon back in London in March, which was about how we built our monitoring system and why you shouldn't. And by the way, I'm entirely sincere. Don't build your own monitoring system from the ground up, unless you like Google and you have nothing better to do because you've already solved all the other problems. I don't know that I have a strong opinion about building your own. Actually, generally speaking, I think you should probably find something for some value off the shelf. I'm a big fan of open source monitoring systems, which is kind of appropriate given that I'm at the open source monitoring conference. I think in some cases it doesn't make sense to do your own. I'm a big fan of PagerDuty as a company that solves a problem I don't want to have to solve, and I'm happy to throw money in their direction. There's a whole bunch of people who compete with them. Here's a correct and useless answer. Do what makes sense for you. And we can geek about that more later if you want. Just 1 second. You know what? I'm going to grab somebody from over there just because I've been paying too much attention to this stuff. Yes?
So with the canaries where you're evaluating current versus current, right, in two different versions, how do you detect slow drift over time where things might be within tolerances?
Yeah, we don't. So I'm not saying that canaries are the way you're going to solve all the world's problems. Canaries give you the answer to a very, very specific question. It is one of the questions I argue you should be asking, but not the only question. The only question that canaries answer is, hey, is the version of the code that I'm releasing right now at least as good as the version of the code that is in production right now? That's it. It's not telling you whether or not the version of the code you're releasing is actually doing anything that you actually want it to be doing. Presumably, you're releasing this because it's doing something different. Let's say to enable a feature, canary testing doesn't actually tell you whether or not it's doing that. It just answers that question. And that's another one of those things, right? If you decompose the process of releasing software into a series of more atomic questions, I find each of those questions is a little easier to answer than if you just go, should I move forward or should I move back? I have a small brain. I like to decompose everything into tiny little fragments. Perhaps that's why I like Twitter. Yes, sir. Sorry. Thank you for your patience.
Yeah, I was just curious how you handle sort of meta monitoring. You popped a metric earlier where 16% of the canary tests have come back bad, shot the service in the head, bring up a new one.
Yeah.
So now you're back to generating numbers from something that you reduced down from numbers.
Yeah.
Ultimately, is that you're going to end up with the same problem? Do you then reduce that again? Is the view of your site ultimately going to become one red light or one green light?
Yeah.
How do you solve that problem?
So the question was basically, how do you handle the monitoring of the monitoring data? This is known in the industry as the yo-dog problem. frankly, at our size, that we end up spending a surprising amount of time dealing with meta monitoring. So I can actually, maybe I'll pop that into the channel on Slack, some pictures of the telemetry products that we built to help our customers know how they use the telemetry platform. Because, so for a while we were growing at about 100% quarter over quarter, metrics-wise. Sadly, we were not growing our business at 100% quarter over quarter. This made Amazon really happy, but made my financial people less happy, because basically the biggest cloud spend Netflix has right now is the telemetry platform. Everyone has said that Netflix built a fantastic monitoring platform that also happens to stream movies most of the time. So we've spent some time helping our customers, especially sort of like the people who send the most metrics, the 300 to 400 million metrics per minute people, both figure out what metrics they send into the system, but also what metrics are wastage. So we spend part of our product development time on essentially sort of meta product development, and I'm happy to talk about that more, but I really do think that Will is going to like drag me off the stage with one of those big takes. So thanks for your time.